During the summer and fall of 2007, 10 UC San Diego students spent a lot of time in laboratories with weather monitoring instruments, electronic data loggers, and routers that send measurements wirelessly to a campus computer. Soon after they attached the equipment to utility poles and tripods on top of university buildings, the weather data began filling that computer. Their sophisticated weather monitoring network amounts to a key step toward helping the university understand how to use ocean breezes to cool its buildings. The network also is being used to identify the sunniest spots to expand the university's solar electric system and to use irrigation water more efficiently.
At home, I'm the person who is shutting off the lights and I'm trying to save the energy. So I think in getting involved in this project, it would help me and the university to do this in a bigger scale.
The students are being mentored by two professors at the Jacobs School of Engineering, Jan Kleisel and Paul Linden, as well as two professors from the California Institute for Telecommunications and Information Technology, Doug Palmer and Bill Hodgkiss. Although it is a student project, this one is unprecedented in the United States for the generation of highly dense, long-term weather records.
So right now we have 5 stations in operation. We're trying to cover the whole range from the ocean to East Campus. And eventually we will have about 20 stations which will be partly on the road at lampposts and partially on building rooftops all over campus where we can have a good information about the weather conditions. We all experience the weather on a daily basis, but you have to really look at data, at numbers to figure out what the determining conditions are. And students can now do that by looking at the entire process of weather stations. So they set them up, they design the mounts, the enclosures, they install them, and then they also help me with the data processing. So we will measure at about 20 locations all across campus the weather conditions, which means temperature, humidity, wind, solar radiation. Anthony, can I call you back? Okay, bye. So my students on the roof.
UC San Diego heats and cools more than 11 million square feet of floor space. Reducing the annual cost of that air conditioning, even by a small percentage, would guarantee significant long-term savings. And that's where the weather monitoring stations come in.
So this a set of micro weather stations throughout the campus is going to give us data that we can then use to plan solar panels, how we design buildings. More importantly, we can use ongoing data from these weather stations to actually change how we cool those buildings. Rather than us saying on an average, in August, we're going to need to provide this kind of cooling or this type of heating. We can say that today, at this moment, the temperature is such and such, and we can throttle the heating and cooling and the energy use up and down in real time. One of the areas that you might not think of when we talk about this network of weather stations is how it might affect something as simple as watering our grass. We use many millions of gallons each year in irrigation and watering on this campus. And like most places, we have them on timers. What this weather station network will allow us to do is to have these, the data of these monitoring stations feed into our irrigation so that in real time we can increase or decrease the amount of watering based on that climate condition in that part of the campus.
UC San Diego is committed to sustainable operations on a variety of fronts. It offers alternatives to commuting by car, an expanded recycling program, more energy efficient lighting, and it irrigates landscaping with reclaimed water. The UC San Diego Office of Business Affairs is providing $20,000 for the weather monitoring network. The Jacobs School of Engineering is contributing $50,000, and Johnson Controls has added $1,000.
Another important aspect of this project is the fact that we're bringing science and engineering and policy together. So we're bringing new information by engineering new stations that we can measure things. We can provide new information about scientific variables such as temperature, relative humidity, and so forth. And we can provide this to the facilities people on campus here so they can make policy decisions about how they want to operate.